Welcome, you marvelous mathematicians, to Lesson 16. I am so excited about all the learning that you've been doing about area. You guys are doing a fantastic job on learning math while you're having to learn from home. So today we're going to start with Lesson 16, Session 1, and we're going to continue our learning about area. Now, what we're going to do today is we're going to actually look at how we're going to add areas. We're going to explore adding areas. So we're going to find the areas of two different rectangles, and then we're going to add them together. Now, let's go ahead and read our instructions, and then we'll go from there. Previously, you learned how to count squares and how to use multiplication to find the areas of rectangles with whole number sides. Use what you know to try to solve the problem below. Now, before we start our word problem, there are some words that we've talked about, but I want to make sure we remember what they are. Our first word is area. Remember, we've been working on area for the last two lessons. Area is the space inside a two-dimensional shape. It is the area inside this rectangle. The area is the space inside this rectangle, and area is also the space within this rectangle. Now, a new word that I'm going to be talking about is the word additive. I want you to look at the word additive. What do you notice about that word? Does anything stick out to you? Do you notice that it has the word add at the beginning? This is the word additive. Say additive. Additive means that you can add the ideas or the numbers together. So additive means it can be added. So when we talk about additive properties, we can add the numbers. Okay, so let's go ahead and look at our word problem. Ayana makes a poster that is 3 feet long and 2 feet wide. Let's pause and think for a minute. What is Anna doing? Ayana is making a poster. Okay, so which poster do you think she made? You're right, the top one. Okay, let's keep going. Raul makes a poster that is 3 feet long and 1 foot wide. How many people do we have in this problem? We have two. We have Ayana and we have Raul. And Raul has also done what? He's made a poster. Which poster is his? His poster is 3 feet long and 1 foot wide. So this would be his poster. I'm actually going to make sure, I'm going to label that. This is Ayana's and this is Raul's. Okay, sometimes, see, this is what goes on in my head when I think about word problems and when I read them. So I want to make sure you know what's going on inside my head when I do math. Okay, so now we know all about Ayana's poster and we know all about Raul's poster. Let's keep going. They hang the posters on their classroom wall, as shown. Okay, they hang it on the wall. What do they do with the posters? They hang them, and look at how they've hung them. Whose did they put on top? They put Ayana's on top, and then we put Raul's right below it. I want you to stop and think for a minute. Think about your classroom. If Mrs. Gonzalez put these on the walls, could you see that poster on the wall? Could you see Raul's poster right under it? That's what we do. We visualize when we look at word problems. Okay, so now what's the question? What is the total area of the wall covered by the posters? I noticed some words. Remember, we've been doing area. What is the total area? Total. That means they want to know this area and this area. What is the total area of the wall covered by the posters? Ooh, do you notice that S? Posters. They want to know the area of both posters on the wall. I want you to think about, how would you solve this? If you just had to solve it right now, what would you do? Go ahead and pause the video and sketch what you would do. Okay, do you have a sketch? So my first thought was to find the area of Ayana's. So Ayana's poster. And I could find out Raul's poster. Now we have to remember some things from lesson 15. How do we find area? Who can remind me? Think about it for a minute. Say it out loud if you know it. Area is length. Oops, there we go. Times the width. So let's look at Ayana's poster. Ayana's posters, how long is Ayana's poster? It is 3 feet. How wide is her poster? It's 2 feet. So remember, area equals length times width. Ayana's length is 3 and the width was 2. So knowing your times tables, what is 3 times 2? Ayana's poster is 6. It is 6 what? Square feet. Okay, how about Raul's poster? Raul's poster, we're also going to use area equals length times width. Okay. What is the length of Raul's poster? That's also 3. And what is the width of Raul's poster? Oh, his is only 1. Okay, let's figure out the area. What is the area? 3 times 1 is 3. Okay, so now what do? I know Ayana's has an area of 6. And I know that Raul's has an area of 3. If I want to find the total area of the posters, what am I going to do with those two numbers? It is that really cool word that I told you about at the beginning. Our rectangles are additive. So when we want to find the total area, we can add the areas together. So when we work with additive properties today, we are going to add the 2 rectangles, the area of the 2 rectangles. So now if I want to find the total area, I am going to add Ayana's poster plus Raul's poster. So let's substitute, oops, I misspelled that. Let's substitute the numbers in. What is the area of Ayana's poster? It was 6. What is the area of Raul's poster? It is 3. What's 6 plus 3? It is 9. So what that means is we have 9 square feet of area. Now, I want to show you something. There is another cool way to do this. So we use the additive property here. So we were able to add our 2 areas. Now, what I want you to think about is what if we actually made the 2 rectangles into 1 rectangle. Notice when they're hanging on the wall, there's a little bit of space here, and we can't count that space in the area covered because this part of the wall is not covered. But what if in our minds, we visually, remember we talked about making pictures in our head, what if we pushed them together? Look at Ayana's poster. Remember, it's 3 by 2, and I colored in 3 squares by 2 squares. So Ayana's poster is still 6 square units, right? Or square, what are we talking about? Feet. There we go. And then I took Raul's poster. Raul has a 3 by 1. So I colored a 3 by 1. And so notice there's no more gap. It's kind of like we pushed them together. How could we find the area of the big rectangle? Do you notice that there is a big rectangle now? We have a small rectangle and a small rectangle, and together they make a big rectangle. Actually, they make a special kind of rectangle. What shape is that? Right, it's a square. So what I want you to think about, what is the length of this rectangle? It's still 3. Whoops, what is the width of our new big rectangle? This is my additive part. I take my 2 and I add 1. 1, 2, 3. So can I figure out the area by combining my rectangles? Let's see. What if I combine the rectangle? When I combine the rectangle, if I have area equals length times the width. I notice that I have a length of 3 times my width. What is my width now? I have 2 plus another one, so my new width is 3. And 3 times 3 is 9. Is that the area we found by using our additive strategy? It is. So there's 2 ways to do this. We can use our additive strategy where we add Ayana's poster area and Raul's poster area, or we can just combine it and make one big rectangle, and we call that a combined rectangle. Say combined rectangle. Very good. Combined means we put them together. Okay, let's go ahead and turn the page over. Okay, what I want you to do in number 1, it says we want to connect it. So we're going to look back. Explain how you can find the area of the wall covered by both posters. I want you to go back, and if you need to, think about the 2 ways we did this. We did the additive where we added them together. And we did the combined rectangle. See if you can figure out how to draw a picture for one or the other, or you can use words. It says to explain. So either draw a picture or tell me how you can find the area of the wall covered by both posters. If you need to pause the video, go ahead. Okay, so now that you're back, we're going to kind of go over the 2 different ways you could have done this. So whatever you've put here, we're going to see if it's either your A or your B. Okay. A combined rectangle is a rectangle composed of more than one rectangle. Ooh, that's something important. I'm going to zoom in a little bit, see if you guys can see that. Notice they did something. They told us a vocabulary word. Combined rectangle. And when they say combined rectangle is, that means they're telling you exactly what it means. A combined rectangle is a rectangle composed of more than one rectangle. Composed is another important word. Composed means it's made of. So let's say it with a made of. A combined rectangle is a rectangle made of more than one rectangle. So a combined rectangle, like Ayana's poster and Raul's poster, is kind of the same thing. This is composed of 2 rectangles. Okay, so a combined rectangle is a rectangle made of or composed of more than one rectangle. I'm going to think about the picture here. Do I have a combined rectangle here? What do you think? We do. This is a large rectangle that is composed of, that is made of 2 smaller rectangles. Okay, so now that we figured out that sentence, let's keep going. You can find the area of a combined rectangle in different ways. Kind of like what we did over here. Okay, look at this rectangle made of 2 rectangles. Complete the equation to show how you can find the total area by adding the areas of the 2 smaller rectangles. Okay, so let's talk ourselves through this. Rectangle A. Everybody find rectangle A. You see rectangle A? Do you notice that rectangle A has this little line right here? That means it's separate than rectangle B. So right now I'm only looking at this space. So rectangle A, remember we are looking at the length times the width. What is the length of rectangle A? You're right, it's 2. What is the width of rectangle A? You're right, it's 2. So now let's use our math. 2 times 2 is 4. So this area of this smaller rectangle has an area of 4 square inches. Let's look at rectangle B. What do you notice about rectangle B? It's the smaller one over here. And notice I'm going to kind of color it a different direction just so you can see that it's different. But it's still the area of a smaller rectangle. Now, we're still working on length. What is the length of rectangle B? It's 1. What is the width of rectangle B? It is 2. 1 times 2 is 2. So our area of our smaller rectangle B is 2 square inches. Now this is the additive part. We are going to add our 2 rectangles together. Rectangle A, right? Rectangle A is 4. Then we're going to add rectangle B, and that was 2. 4 plus 2 is 6. So we just did this using our additive property, right? So we can add, actually, I'm just going to use the word additive because it tells us that we can add them together. Okay, now there is part B. There is a second way to do this. Think of the 2 rectangles as one rectangle. So think about these 2 rectangles as one big rectangle. So now think about this entire rectangle. This whole rectangle, like the whole thing. Do you see that? The whole rectangle. Okay, so complete the equation to show how you can find the total area by multiplying the side lengths. Now remember, we are going to look for our length and our width to find the area. Okay, what is the length of our rectangle? Now remember, this one's 2 and this one's 1, and we're going to use our additive idea that we're going to add 2 plus 1. So what is the length of our rectangle? It's 3. Now, what is the width? The width is still 2. Did that change? No, because we didn't add anything to the width of it. We only added the length. Because notice that we kind of moved it, it just got pushed together over there. 3 times 2 is 6. So 6 square inches. Notice that I have the same answer, 6 square inches and 6 square inches. These two are the same. And since they are the same, we did it right. Okay, now what I want you to do is the little reflect. Now, I've already planned my answer, but I want you to read through the reflect. Why do you think both strategies give the same total area for the rectangle? Pause the video and write down, why do you think both strategies worked? Okay, let's take a look. Both strategies find the area of the same rectangle. So we're still looking for the same area. We can either find it by using the small rectangles. And so that is our first strategy. You can decompose. Have you guys talked about the word decompose before? Decompose means to break apart. So we have our large rectangle that's been broken into 2 pieces. We've got A and we've got B. So decompose means we break the area into 2 parts. That's going to be important for our lesson later on. The second way is we use the additive idea. We thought of the 2 rectangles as just one rectangle. So they both work because we're looking for the same space. We just did it in 2 different ways. Okay, now it is actually your turn to take a look at the independent practice. Now, before you get to this, remember, the green is the independent part. So I want you to go through this and I want you to try to figure it out on your own first. Remember, this is our graphic organizer. We always talk about what we know about area. So think about what you know about area. Fill in each box. Use words, numbers, and pictures, and show as many ideas as you can. And then try working on some of the problems on your own. When you're done, go to video number 2, and I'll go over the solutions with you.